Good day, my esteemed viewers. Welcome once again to K2 Concept YouTube channel. And I remain my humble self, Dave Kome. Now, in our previous video, we explained how to implement the Lo's method for solving quadratic equation. And we looked at an example where our A was equal to 1. So now we're going to be looking at a situation whereby the value of our A is greater than 1. How do we solve such problem? The first thing we have to do is to divide through by A, and our A here is 2. So if I divide through by 2, I will have here to be 1, here will be 3 over 2, and here will be 5 over 2. Now let's implement the Lo's method. Please, if you have not watched our previous video, go back. You will see the algorithm of Lo's method. The first one said minus b over 2. That's the first step in the algorithm. And our b here is 3 over 2. So it becomes minus 3 over 2 divided by 2. Now if you solve this problem, minus 3 over 2 divided by 2 gives us minus 3 over 2 times 1 over 2. And that is how we got minus 3 over 4. Now the second method said we should have the value we got in step 1, we should add a constant or subtract a constant from it, which is plus or minus k. K is now the constant. Then the next thing is to implement by saying minus 3 over 4 plus k times minus 3 over 4 minus k. And we said if we multiply this, we'll get this answer. But we are told to equate it to our c. And our c here is 5 over 2. Please take note of that. Now from here, minus 3 over 2 will give us 9. Minus 3 that will give us 9. Then 4 square will also give us what? 16. Then if minus 5 comes to the other side, it becomes minus 5 over 2. And if k square crosses over, becomes plus k square. And if we implement this result, LCM is 16. 16 in 16 is 1. 1 times 9 will give us 9. Minus 2 in 16 is 8. 8 times 5 is 40. So we're having 9 minus 40 over 16 equal to k squared. Now, if we subtract that, we have minus 31 over 16 equal to k squared. And we take the square root of both sides, we have this as our answer. Now, don't forget, this is a complex number. Why? Because we're told in complex number that square root of minus any number will produce I, because square root of minus 1 is I. That is how we're having I outside here. Then square root of 31 gave us 5.57. 5.57. Then square root of 16 will give us 4. Then equal to what? K. Then the last method said we should substitute the value of our k into equation step 2. And step 2 is this. Then we have minus 3 over 4 plus or minus our k is this. Remember I told us in the last video that we can select any of the value, either positive or negative value of k. And if you implement the positive side, we have this. Then if we separate the two answers, we have minus 3 over 4 plus this, or minus 3 over 4 minus this from this place. Then equal to, if you solve this problem very well, this will be our answer. Now let's look at the second example, the third example rather. The first thing, the value of a is greater than 1. We have to divide by what? 2, which we did here. And we had this result, which is this place. Then the next thing, the first step, minus b divided by 2. And our b here is minus 5 over 2. That is how we are having minus 5 over 2 divided by 2. Then, which is now equal to, because minus times minus will give us plus. So we are now having it as minus 5 over 2. Remember we said minus 5 over 2 will be times 1 over 2. We did this in our previous previous example. Now our next step is to add or subtract a constant, which is 5 over 4 plus or minus k. And if we implement the square root, or we multiply 5 over 4 plus k times 5 over 4 minus k, we'll get this result here. And don't forget, we are asked to equate it to c, and our c is minus 7 over 2. And if we solve further, 5 squared is 25, 4 squared is 16, minus k squared equal to minus 7 over 2. Now, if you solve this arithmetic, minus 7 over 2 coming inside becomes plus 7 over 2. Then k squared going outside becomes positive k squared. And if we solve this mathematics, LCM is 16. 16 is 16, 1 times 25. Then plus 2 divided by 16 is 8. 8 times 7 is 56. We're having 81 over 16 equal to k squared. Then we take the square root of both sides as we did in the previous examples. We have 81 divided by 16. Then the final answer becomes plus or minus 9 over 4, which is the value of our k. Then we are asked to substitute the value of our k into step 2. If we do so, we have 5 over 4 plus or minus 9 over 4, which we can split into 2 to be 5 over 4 plus 9 over 4, or 5 over 4 minus 9 over 4. And at the end of the day, we have 14 over 4 or minus 4 over 4. And at the end of the day, final answer becomes 7 over 2 or minus 1. So we can see from the previous examples and the one we just implemented now that the Po Shen Loh's method is easier and faster to implement when solving quadratic equation, either when the value of a is 1 or when the value of a is greater than 1. So I will urge us all to implement this method when solving quadratic equation. And please do not just watch our videos. You can go back to our previous videos also. Do well to like those videos, subscribe. Also drop your comment for improvement on our YouTube channel. Thank you for watching. This is K2 Concept YouTube channel.